Okay, so B is equal to 2 over 1. The slope is the change in y over the change in x. So we could say, because the variables x correspond to the market, we'll refer to this as the market. So wherever we see x, we're going to refer to it as the market. Okay, market. And so for a 1% increase in market returns, BCE returns increase by 2%. That's the interpretation. You start here. So you talk about the change. I'm going to say increase. And then it tells you how y changes. Okay. So what if there's a 5% increase in market returns? What will the change be in BCE returns?
Uh, 10%.
Right.
No, with 2%, then it would be 4.
No. Say you did it right. So it's 5 times 2.
Oh, well, if it's 5, then yeah, it would be 10. I
Yeah.
just read the 2%, but yeah, it would be 10.
Yeah. So then this would be, 5. So basically it's double. What if, so this, as I explained, this relationship only exists within the range of values, and the values are all positive. But let's say, just to interpret the slope, and let me say one more thing before I feel like I miss saying it. This is the explanation. This is the equation of the line here, because the A was 0. I put a hat on here. Why did I put a hat on here? Why didn't I just write y equals 2x?
Isn't this change by the one that you change on the x, it increases by the 2? Or it should be like the point where you start.
Is it because
Are you answering my
because it
question or
was
asking me a question
Asking you the question.
about what this means here?
Yeah, because I'm confused. Is it like the slope, like where the point is, or the change of the slope?
Nope, that's change of x. So as the value goes over by 1, it has to go up by 2. If the value goes over by 5, y has to go up by 10. So it's the value of x
Okay.
to maintain the relationship. Again, if you guys have any questions about statistics, you got to go back and watch the statistics videos, because this is just a summary. I'm just giving you the summary of the 5 hours of statistics review, because this is not a statistics class. This is a finance class. And I already spent enough time on it. So the question was, why is there a hat here? The hat is here because the relationship only exists in the range of values. I cannot make predictions far outside the range of values and have any credibility with those predictions. Having said that, at the same time, I could say if there's a 1% decrease in market returns, what happens to BCE returns?
It should be increasing by 2%.
How much? Increasing or decreasing?
Increasing by 2%.
No. Yes. So the -1 would be a 1% decrease in market returns when there's a 1% decrease in market returns, BCE returns decrease. How much? 2%. Okay. So the slope maintains a 2, always a positive 2. So if it's a decrease, then it's also a decrease. So they go in the same direction. Okay, they go in the same direction. Questions about that? When I look at the formula for the slope that's been calculated by optimizing optimizing or minimizing the sum of the squared residuals, that's how that's calculated for the slope. And then you find the equation of the line by methods that we've learned before, using a point and this slope to get the equation of the line. The most important thing I want to talk about right now is the slope formula itself. It is made up of R, SY, and SX. R and B have the same sign. How do I know they have the same sign? Because SY and SX are both positive. They'll always be positive because they're the square root of the variance, which makes them positive. So they'll always be positive. So that means that if R is negative, B is negative. If R is positive, B is positive. Okay, so the slope and the R are related. They have the same sign. In other words, they have the same directionality. They reflect the same direction. However, they're used for different things. R is the strength, and B is the proportional relationship or the direction. R is direction and strength. So it tells you the direction and it tells you the trend, the slope. In terms of all these formulas here, you can get all of them on your calculator, except covariance doesn't come out. If you remember what we did last class, covariance doesn't come out of your calculator, but R does, and the two standard deviations do. So you could calculate covariance. Do you see how? How can I get the covariance?
I mean, you
By-
use the formula on the right. Because, okay, yeah, no, all right.
Okay, so you can find covariance by cross multiplying the standard deviations up. All right. Talking about this now, you can get this out of your calculator. You can write the formula on your formula sheet, but I have a simple mnemonic. If you couldn't, this is how you would remember it. That you have to take R and then multiply by first by the standard deviation of Y and divide by the standard deviation of X. Okay, so that's what that's for. But it's not just a mnemonic device. It actually means something. We interpret the slope, the B or the beta, as a measure of risk. And I'm going to explain more in this unit. But this is like an overview. And all that I'm teaching you right now, I'm trying to tie together with what you learned in statistics and make you realize you've learned this before, but in the context of finance, this is what we're going to do. This is how we're going to use statistics. So it's a measure of risk. Why is it a measure of risk? Well, it's a measure of sensitivity of BCE's returns to market forces. In this case, we would say BCE is sensitive because it's double. That's a lot, okay? So when the market does well, BCE does better. When the market does poorly, BCE does worse. All right. So it's sensitive. If it was 1 for 1, if the beta was 1 or the slope was 1, then you would say it's just as risky as the market. It's neutral. But we would say this is sensitive. So it's a measure of risk. It's a measure of sensitivity. And it shows us how the returns to this, the investors in this corporation respond to market returns or market volatility. Or what we're going to use it for is to say by adding this asset to our market portfolio, this is how we interpret, an increase in sensitivity. All right, so the last thing I want you to do with this is you have all these formulas. These are the ones that you would put on your formula sheet, I think. But I have created also another document with all these formulas in finance notation, and I'll talk about that at the end. For now, I want you to take this formula. I want you to substitute this in here and come up with a second formula for the slope. Okay, so this one is here on this sheet because this is the one you probably saw in statistics. You guys can tell me if I'm wrong, but this is usually the one you see in statistics. But there's another formula that you can derive by substituting R into here and simplifying. What do you get? I can't do this as nicely as I want. So I'm just cleaning. You guys are working on that, right? Easier to do it like this. So B is equal to covariance x comma y divided by standard deviations. And now I'm going to put standard deviation of y over standard deviation of x. Then I'm going to simplify. And I get so what is Sx squared? It's the variance. Okay, so Sx squared is the variance of x. So it gives me a measure for every unit of volatility or variance in the market. It gives me the covariance of x with y. Okay. That's what B is. So it's a standardized way of looking at the covariance, which is exactly what I wanted from here. But this measure of covariance doesn't narrow it down to a measure I understood. So I standardize it to get R. But here it's telling me the covariance, scaling it for every unit of volatility measured in by the S&P 500. Okay, so for every unit of variance next, this is the covariance of x with y. That's B. So those are the two formulas for the beta or B slope, however you want to think about it, and measure of sensitivity of market returns on stock returns. And I have just given you an example there of that stock, but I could give you any. So in general, the market returns will be on this axis, X, and the stock returns will be on Y. Any questions about ex post historical data and all these statistics? You should be able to calculate all of these without problem. What if your data appears to you as ex ante data? Ex ante data is generated as a distribution where there's 3 possible outcomes. So this is taking fundamental analysis, prospectus, all the information we can about forecasts of the market performance to come up with this distribution. 3 possible outcomes have been determined. Either the economy will be in a normal state. There's a 50% chance of that happening. The market will be in an expansionary state with 40%, or the market will be in a recessionary state. These probabilities sum to 1. And we see the possible returns, or the returns that are estimated with these different states of the economy. So this is a simplified population distribution. So we actually here have only 3 possible outcomes with predictability provided here, or how much we, what weight we put on any of these things happening. So because there's weight, and because every data point has different significance or provides different, has a different weight of importance, we need to use slightly different formula, more general formulas from those above. We're going to use the weighted average, the weighted standard deviation, the weighted covariance, and so on. And you should notice that I'm using these Greek letters. Now, why am I using the Greek letters? Greek letters are reserved for parameters. So what we have here are population parameters. So above were sample statistics that we were calculating. And so remember, sample statistics as opposed to population parameters. So parameters are the term reserved in statistics to refer to population characteristics, the population mean, the population standard deviation, population covariance, and so on. This is the letter M for mean in Greek. This is the letter S for sigma. Sorry, S, or this is the letter sigma in Greek, or the letter S in alpha in our alphabet, and for standard deviation. And this is the notation we're going to use for covariance. The one that I give you on the platform has a little X here. And notice that instead of X bar here, I'm going to use the true mean, mu X. So it looks a little bit different, and I'm going to carry this weight. There's always a weight in each of the formula here, okay? Differentiating the weight from this. This is the Greek letter R. Looks like a P, but it's not. It's a Greek letter R, or rho, for correlation coefficient. Greek letter R. And then these are all the same formulas or the comparable or analogous formulas to those above, but I'm using Greek letters. And because I have the true mean, I use that, and I don't have to divide by n-1 or any of that. I'm just using the weights inside. Now, that's not to say that these ones have weights in the ex-ante data and these ones don't have weights. These have weights too. What are the weights of these data points in the post data?
I would say they're all equal.
They're all
So they're all
equal.
20, 0.20.
Exactly. They're all equal. They're all 0.2 or 1 divided by 5. That's what that is here. So we actually did use a weight, but it was the same for every value because every value had the same significance. All right. So what we have below is where they're different, and they're different. So we need a slightly different formula to account for that. What I want to do now is calculate a few of these and leave it to you to work on. Hopefully we can get to the notes. Did that in 45 minutes. Okay, so let's get the mean. Oh, wait, before I go there, can anybody tell me, looking at this, what is the relationship between X and Y? Would you be able to, can you see the slope or like we did above?
Well, it should be a little more than 2, but I don't think I could tell you like the exact one
Right,
right
you
off the bat.
can't, right? It's not, so I give you this very simple example here where we can see it clearly. It's always exactly 2. In general, that's not going to happen. If I gave you a regular set, it's probably going to be like this, and it's going to be hard to see. You're going to get a rough idea because there's going to be a notion that when X is something, Y is, up, it's higher. So that makes it a positive trend that it's going, that this is higher. When this goes up, or this is lower, this is going up in the same, how am I going to explain this? I think it's more about the differences. Anyway, it's easier to see here because it's about double each time. Okay, there's no variation from that trend. But if you see it, if it's an approximate doubling, then you're going to expect it to be near 2. You can't say that about this data because you can't treat every data point equally. This happens 50% of the time. This happens 10. I don't know how to look at that. Okay, so we don't have an intuitive way. It's just like if you guys taken linear algebra and you learn about 4 dimensions, it's hard to visualize, right? So, but we do have our statistical tools to tell us what exactly, in a standard way, what exactly are we looking at here? So I want you to find the same statistics, or in this case, parameters, mean, standard deviation, covariance, correlation. So I'm going to get you started, and then I'm going to leave it for you to practice. Okay. So let's start with this. Let's get the weighted mean. I'm going to take this data. And what I have to do is multiply across and sum, right? So this is how I would do it manually. I do expect you to be able to do this for the test with at least 3 values. And there's lots of practice. I'm going to add even some more documents to your set of documents. So I'm going to bring up my calculator. And I can do 0.4 times 0.14. So this is the slowest way to do this. I'm going to show you the faster way to do this. And I can store that in 1, and I can take 0.5 plus 0.08, and that's 0.58. and then 0.1 times 0.04, which is 0.004. Did I do it right? One,
The second one is off. The second one should be 0.04.
I don't know what happened there, sorry.
Yeah, it's fine.
Okay. Yeah, I knew it looked weird. Okay, so then it's 0.04. So it's 0.04 store 2. So recall 1 plus recall 2 plus recall 3 should give me the answer, right? So recall 1 plus recall 2 plus recall 3. And I get 10%. Remembering that these weights total 1, so it's a legitimate, this is a legitimate distribution. All I have to do, because I've pre-weighed each value, I just sum them and I get 10%. A faster way to do this is the following. I'm going to use my stat mode. There's something in there, so I have to clear it. And I'm going to enter the probabilities as X and I'm going to enter the returns to the market as Y. So I'm going to put 0.4 enter down as X1 and 0.14 enter down as Y1. Okay, so that's my pair, X and Y. The next one, 0.5 enter down and 0.08 enter down for the second data point, and then 0.1 enter down and 0.04 enter down. So let's check. I'm going to check. All right. Now that it's all in, I'm going to hit second stat, and I'm going to use the arrow up to get the answer. And you see, I got the same answer, 10%. So you need to remember that, those steps, write it down, what I did. But this gives me the sum of the products, the sum of these multiples. Can you guys try that? So until the end of the course, you guys got to remember how to do these things. I hope you remember it forever, but at least then. And now let's move to looking at calculating the standard deviation. Well, actually, let's get it for Y. So I'll let you get Y. So you're going to put in for Y, you're going to enter B's as X and for probability, and then Y will be just the Y for the index. Entering those, I'll do it while you're trying. So I'm going to go back to data, clear it up. And I'm going to put in 0.4, enter down, and the Y would be 0.3. And then 0.5, enter down, and the Y would be 0.18. And 0.1, enter down, and Y would be 0.1. And then I hit second stat and arrow up. So it's 22%. All right, so how are we going to do this in an efficient way? The calculator, the 12C, the HP 12C does do weighted calculations. Again, I didn't ask you to buy that one. It is better for the weighted statistics, and it is better for obviously the getting multiple IRRs. But you can tell me if you're upset that you don't have it, but usually that calculator is much more. So recently they're about the same price. But anyway, this is what we got to do with this calculator. So right now I have that mu x is equal to 10%, mu y is equal to 22%, and I want to get sigma x and sigma y. So to get sigma x and sigma y, I recommend you see this as 3 brackets. So I'm going to express this. This is, remember, the deviations from the mean squared. You want an average, so it's a weighted average deviation from the mean squared with a square root. So I see that I need to put the deviation from the mean. So I need, for sigma x, I need to take all these values and put them down like a column. So this is like Excel. You can't bring Excel to the test, but if you want, you can do your assignment questions, your problems with Excel. It's just you need to practice with the calculator as well. So use your time wisely. So I'm using columns. I'm transcribing from here, and then these are just the means that I calculated for that one. Now I have to pre-multiply by 0.4, 0.5, and 0.1. Add them together. And what do I get? I will get the variance of x, or sigma squared x. So how should I do that on my calculator? What I'm going to do is calculate this and store it. Calculate this and store it in 2. Calculate this and store it in 3. And then use the same technique I did before, getting this statistic out of the calculator, okay? So, are you guys watching? Are you trying? Okay, I'll let you try it. I'm going to stop. You guys try it without me. And then I'll do it. Did you do it, Diego, already? Diego Hernandez? No, not yet. Okay, just try it. Let me try and display. This is hard. I will drag the formula over. All right, so I'll start. Second data, make sure it's clean. And then 0.14 minus 0.1 and square and store that in 1. .08, I'm going to the second bracket, minus 0.1 equals squared and store it in 2. And finally, this one, third, 0.04 minus 0.1 equals squared and stored in 3. And then put them into the worksheet for the data. So the data worksheet will have, I'm going to make the probabilities x and these deviation squared as y. So I'm going to put 0.4 and recall 1 and 0.5 and recall 2 and 0.1 and recall 3. And I'm going to check my work because I have to check. So let's see, 0.4, 0.2, 0.5, and 0.1. And then what do I do? Second stat and arrow up. So the variance is 0.0012. You can get the standard deviation by taking the square root. Which is 0.0346. So usually just follow the directions, how many decimal places I want you to hold. But that should be fine. So about 3.4%. Remember, we do not put a unit. You do not put a unit on the variance. Good. Okay, so questions about that? Any comments? So you should be able to get the standard deviation, the covariance. Then you take the covariance and you divide by the two variances of standard deviation, sorry. And then you can get the slope. The answers to verify your work are on the platform. Everything is on Moodle. Let me show you where it is. And let's have a look at that, unless you have any questions about this.
Professor, just to be clear, the .0012, that's the, I want to say it's the standard deviation, or is it the variance?
It's a variance. Yeah.
That's the variance, and the
Yeah.
standard deviation is the .03
Yeah, that's why I put the
for.
square here. Yeah.
Okay.
That's
Clear.
right. Did I do it right, or were there more zeros, or let me see.
No, I got the same thing.
Okay, good. So let's look at, unless you have questions, I want to look at a couple things on the platform. Okay. Let's go to Moodle. So I don't want to intimidate you by showing you all this and saying you need to know it, but you know it, like you've seen all this before. It's just a matter of organizing it. And I've done the best I could by putting it all on one page for you. And encouraging you to work out these exercises and have them as a resource. So the exercises are here. This is where we started. Expose data and their sample statistic formulas, ex ante data and the sample statistic formulas. And then I have the solutions here. I have them separate because there's a lot of pages. There are a lot of pages. So this one was the one that we did earlier. And then this is ex ante. So what I've done here is tried to work with columns, put everything in columns and get the results. We just did this one. You could get this one for Y. Take the square root. I put it down here. I kept both values because these come in handy. Like the variances come in handy. I calculate here to get the okay, so I use all the data from above and I get the correlation coefficient by finding first the covariance and then dividing by the two. So standardizing the covariance, same thing, columns, working with the columns. The messiest one, I guess, is the covariance. So make sure you practice it. Notice what the answer is. the correlation between X and Y, although you can't visualize it, is perfect. All right, so it's a perfect predictability you have for this relationship. And you can make an equation of a line with a slope, and it happens to be also 2. Couldn't see that in the pattern of the data, but that's how it works out. Okay. So I want you to try and replicate these. As messy as this is, the results are very simple, so you'll know if you did it wrong. These handouts are on the platform. Any questions? So from today on, I expect you to be good at this, right? You got to be reliable on this. I want to show you the document here I mentioned. These are the same formulas, but in finance notation. So how did I do that? What do I mean finance notation? It's the same data, the same variables, but the notation is going to use R for return and M for market, and R for return and I for the stock. So that's more general. Any stock I use will have an I subscript. So even though this looks intimidating for many people, these formulas look new and intimidating. They're going to be the formulas in the notes, and they're going to be the formulas in the textbook. But you're fine. You guys are fine because you know these formulas, all right? So you're going to know the simple ones from the statistics that you learned. These are the analogous formulas. All that separates the top and the bottom is the notion that this is a sample, ex post historical data, and this is a distribution of the population of outcomes. So when you stare at this, you shouldn't be worried. Just let's be curious. Okay, let's look here. So what does this say? This is like X bar. We're going to call it R bar. We're going to add up all the R's and divide by how many there are. That's just the average. Then here, this is going to be the sample standard deviation. Notice I don't use S and I don't use sigma. I use sigma hat. Why do I use sigma hat? Because it's an estimate. The hat means that it's an estimate because this is just a sample. It's not the population. So that's what the hat's all about. Okay, so you don't have to write these formulas out. Remember, I don't need to see the formulas on your test. I need to see the formulas with the data inside. The reason I'm showing you this is demonstrating that it's the same thing as what we just did the last class and today. Notice here, this is the covariance. I wrote it here, covariance of X and Y. But I've written them in alphabetical order because in statistics, usually they write them in alphabetical order and I comes before M. But which one is X and which one is Y? So which one is X? Which represents the horizontal axis?
The market.
The market, very good. So it should really be MI, but I stuck with the statistic notation putting IM. If this becomes confusing, let me know. There's a lot of subscripts here and things. Don't let it intimidate you. If it bothers you, again, just go back to this formulas here to help you. Okay, just to help you read. But notice it's the same formula. Same formula. That's covariance. This is correlation, standardizing the covariance. And then this is, the two formulas for beta are here. The beta hat, because this is just an estimate, it's not the true or population beta. So I put a hat on it, and then I put hats everywhere because they're all estimates. But what is it? This is R, SY, because I represents this index or the stock. Sorry, it's the subscript for the stock. And divided by SX. X is for the market. So this is just RSY over SX. It's the same. This is the second formula we derived. This is the covariance divided by the variance of X. So those are the formulas in the finance notation for ex post. These are the notation for ex ante. The subscripts, sorry, this is for the means of whatever you use, whether it's the market or the stock. This is the standard deviation, whatever you use, market or stock. This is the, notice this is the mean here. Notice sometimes I'll write ER. That's the expected value of the returns, but we know that that's just mu. So there's a lot of notation to say the same thing. The main point is that you identify if it's exposed data or it's ex ante data and not get too caught up in all this notation. This is just the covariance. You have the deviation from the mean for the stock. You have the deviation from the mean for the market, and then the weight. Then you standardize the covariance for the correlation, and then R, SY, SX. What I want you to do is practice all of this by completing our next class, review 1 on risk and return, review 1, question number 9. You're going to get practice to calculate all of these with the finance notation because we've graduated to finance notation. Can you do that for me?
So by next class, we should do question number 9 of review 1, and you will give us a 5% bonus. Did I hear that correctly?
You don't need a 5% bonus. You guys are going to do great. You guys, if you guys do this, well, if you submit it to me, but I don't know, because how do I know if you guys really did it? That's the problem. Let's think. Well, if you do it, maybe you can count on me putting one of these, like a question like this on your exam. How about that? And you would have already studied it. So that's your bonus. I don't know. This takes a while. This will take a few hours, I think, as you're learning, unless you really know this already. Okay. So if you don't finish, you don't finish, but let's see how far you can get for next class. What else can I ask you to do? So I want to start, I do want to start the notes. I do want to start the notes. Let's see. So what we're going to do in the notes, let me just give you a preamble and then I'll let you go. What we're doing in this unit, we begin with talking about returns. So we spend some time calculating returns. So I teach you about where these numbers come from. Okay. Well, we're not going to do it for the S&P 500 because that's a little more involved, but we're going to calculate the returns for stock, dividend paying stock. And that's where we begin. Here. What is a return? A return is made up of, dollar return is made for stock, so risky asset. A dollar return is made up of the dollar dividend you receive in a period plus this. What is this? Can someone tell me? It says it there in words, so you can just read it out if you want.
Change in market value.
Thank you, Denzel. Change in market value, right. How do we calculate the change in market value? If we want the dollar return for today, so think of T as today, then it's going to be the dollar dividend today plus the change in market value, the price today minus the price 1 period ago. So that's what the T minus 1 is. So when you see those, again, more notation, no need to be intimidated. Just ask me if you don't know, why is that a T? So we'll interpret it as today or now. So if you're holding stock in a company and you've held it long enough, like 3 weeks, you're entitled to $1 dividend. And then if from the moment, the last period when you bought it, the price went up, you're going to experience a positive change in market value. And that adds value to your return in dollar terms. Whether you sell it or not, I've said this many times, whether you sell it or not, it has value, and that is its value. Okay. Now we want to convert that into a percentage because I never showed you dollar return data. I'm showing you percentage return data. So percentages are relative. Statistics is about averages and relative measures. So what are we going to make it relative to? Well, dollar return from the past to today. Notice I used last period's price as a reference point. So I'm going to use that to get the percentage return. I'm going to divide by the beginning market value. When I do that, mathematically, this is what it looks like. So I'm taking the thing from above here, the one thing that we were looking up, the dollar return, and I'm going to divide it by last period or the beginning market value. That gives me RT. All that's giving me is this, for instance. So we've calculated one cell in our table. I could also write that this way. I could separate what I will call the dividend yield. This is what, looking at the original price, this is the yield on the as calculated through dividends. So the dividend yield, we're separating those two because you would actually pay a different tax rate for dividends as you do capital gains. So that's a common way to divide the return. And you hear about dividend yield, capital gains yield. Capital gains yields are not realized. You don't put that in your pocket as cash flow until you sell the asset or sell the stock. But dividends you will experience without selling the stock. So we separate those two out because they have their own distinct treatment and understanding. So this is the capital gains yield. Any questions about that?
No.
No? Okay, thanks. Another way we could represent the return is to separate, often we talk about rates, how we do the -1 sort of thing, right? When we do interest rate conversions, we try and find the percentage return. Trying to find the interest rate for every dollar invested. So we have to take, -1. Anyway, this is the same sort of notion where we can look at this as the for every dollar invested, this amount, is net of 1. So if we're getting more than the dollar back, this should be much higher than 1. If we're getting less, it should be much less than 1. It's another way to calculate the return, but it's the same data, same notation. Okay. So usually people will talk about it this way, but the calculation is made this way. The first way. All right. So here's an example before we go. calculate, using this information, calculate the dividend yield and capital gains yield and the total percentage return for stockholders in this stock. I need to put the formulas down. Let's see. I'm going to open it on my iPad so I can show you both formula and then we'll go. So suppose the stock had an initial price of $42. So which symbol is $42?
The 42 is the PT minus 1, right?
Or initial price. Very good. That's the PT.
Yeah.
one. Paid a dividend of 84 cents. So what's that?
DT.
That's the DT.
That's easy, right? DT. And had an ending price of 46.2.
That would be PT.
There you go. So you guys can get that. Okay. So you guys can get that, compute that, check your work. I think I have the answers there, or we'll talk about it. Let's see. No, we'll have to go over it. And we'll see you on Thursday. Work on review 1, question 9 for next class. Okay. Bye for now. Diego, I saw your message.
I got 12%. And I have the same question as the Hernandez.
Yeah. I'm still working on it, and I got to post the grades, but let's aim for before the next class. I will aim for it. You guys,
All right, thanks,
keep putting
Professor.
pressure. It'll help me feel pressure to
Okay.
do it. Okay, you guys, we'll talk to you soon. We'll see you Thursday.
All right, have a good day, Professor. Bye.